So we are looking at department paper here, DBE May-June. May-June is not written there. May-June 2027. No, 2017, sorry. 2017 May-June paper. So this paper is written by those who are doing what? Who are either rewriting or planning to complete their metric. All right, so fine. I'm looking at question 4. Yes, I'll be doing that, Pasha. I realized, okay, let me just record my screen here while you also interact with me live at the moment. Right, so I'm looking at 2017 DBE paper. That is May-June. So we're going to look at the paper and see best ways to help each other respond to these questions. So I'm gonna read the top part and okay, let me just take it down. Let me take it down like that. So it says a flow chart. It says a flow chart or a flow diagram below shows an alkene. Shows an alkene. So once we talk about alkene, you need to know what that is. An alkene is that compound that we say it is what? Unsaturated. An alkene, we know that it is a hydrocarbon, that's number 1. Hydrocarbon. And it is unsaturated. Since we are dealing with chemical properties, we expect this compound to undergo addition reaction. We expect this alkene to undergo addition reaction so that we can break down the double bond, so that we can fill in, or the new atoms can be attached to the carbons that were supporting the double bond. All right, and we must know there are 4 possible addition reaction. There are 4 possible addition reaction where we can add hydrogen. We can add hydrogen, we can add HX. We can add hydrogen bromide. We can add, X2. We can also add water. We can add that. So these are 4 types of addition that this alkene can undergo. When you add hydrogen, we call it hydrogenation. When you add hydrogen halide, we call it halogenation. When you add a halogen, we call it halogenation. When you add water, we call it hydration. So those are 4 possible, and you must know conditions for that. And I can say here we expect a catalyst platinum. We expect a catalyst platinum there. Let me see if I can add these AirPods. Maui. Yo. Hey. All right, it's fine. So, and when here we need what? With HX, okay, let's say here we need sulfuric acid, H2SO4. And this one is spontaneous, it's just room temperature there. So here I would say no water is needed. No water must be present. So here we also need a non-polar solvent. So these are things that you need to remember, the reaction conditions. So now they're saying this alkene can be used to prepare other organic compounds. Okay, other organic compounds, which I mentioned there, 4 possible organic compounds that will come out from that. Then, what's that? So we have 4 possible organic compounds that we can form under an alkane which undergoes addition. So the letters A to G represent different organic compounds. So I'm going to start by highlighting the compound, the main compound here. This is an alkane. It's an alkene. And I just mentioned that an alkene undergoes addition reaction. And we must also know that an alkene, it is unsaturated. An alkene, it is unsaturated, which implies that there are multiple bonds. There is at least one multiple bond between carbon atoms. So this has to do with carbon atoms. Thank you, Sally. Thank you, Sally. So it has to do with what do you call that? It has to do with carbons. There is a multiple bond there, double bond. So that's why we call it an unsaturated compound. Now, I mentioned that an unsaturated compound will undergo addition reaction. So undergoing addition reaction, that means you must look for arrows that are going out. Let me highlight those arrows that are going out. Maybe let me put red there. This arrow here is going out. This arrow here is going out. This arrow here is going out. And this arrow here is going out. So you see, there are 4 of them. There are 4 of them that are going out. So since there are 4, there's a possibility of what I mentioned when I was talking to you here. H2X, HX, X2, H2O. But let's find out if it's really all of them that are mentioned. But by look of things, I see water. I see water here. So when I see water, I must think, okay, I'm moving from an unsaturated compound. I'm adding water. So when I add water, it means I do need sulfuric acid. But now the question is, this sulfuric acid concentrated or diluted? So in this case, it is a dilute. Sulfuric acid, because I'm adding, I'm not removing water. So yes, so as such, we are then going to say, okay, we have done that, we need that. Fine. Let us look at reaction A. Reaction A is moving from unsaturated to a propane. Propane is a saturated compound. It's an example of an alkane. So alkane is saturated, and we are moving from an unsaturated compound to a saturated compound. Oh, it seems like the A is giving us a hint there, but that is not the case. So this is another addition. So I mentioned this is also addition. So it's addition. So also this one, it's addition, as I've mentioned. It's addition. And this one is also another addition. So since now we have established addition, so from unsaturated alkene to a propane, so that means the new atoms that must be added from a hydrocarbon unsaturated to a hydrocarbon saturated, that means here we are going to add H2. And I mentioned the conditions here. We need a catalyst, and the catalyst is platinum. And we also need a polar, okay, not polar, but non-polar solvent. And I mentioned you could be talking about CCl4 as the non-polar solvent. Right. So with that being said, I've spoken about that type of addition, and we can specify this compound undergoes hydrogenation. It undergoes hydrogenation. Okay, fine. Let me go back to that one, the water part. This one, we call it, this compound, I don't know where to write. It undergoes hydration. It undergoes hydration. But also, I'm going to start asking you to also give inputs onto this. What kind of addition reaction is this one, where HBr is added? What kind of addition reaction is this one? Let's hear your input on this one. What kind of addition reaction is this? Halogenation, number one. So it's halogenation. You are very correct. Halogenation. And do you still remember the reaction condition for this one? Black is brown. I see you, Khotatso. Thank you for coming through. Yesterday you didn't come through when you asked me to actually start this lesson. Any reaction condition that you may recall for hydrohalogenation? It's okay. It's okay. Reaction condition for halogenation, for hydrohalogenation. That is dehydrohalogenation. That is 3 products. Dehydrohalogenation is the one with 3 products. So here we are adding secamides. Which is actually the reverse of oh wait, is it reverse? Yeah, should be the reverse. Yeah, it's the reverse. No catalyst needed. Is it not the one there we say we don't want water here? No water present. No water. No water. No water must be present. Room temperature, it is the Br2, where you add the halogen. Ne? Okay. Okay, so, and here also, we can conclude the same thing, stating that this is also a halogenation. So it's hydrohalogenation, similar condition, no water must be present. And compound Y, okay, sharp. I think I spoke about all the addition reactions, ne? And their reaction conditions. No water. No water must be present. Okay. And so I'm done with those ones. But first, before I move on to the other ones, let us then state whether the compounds are saturated or unsaturated. Remember, we are taking an unsaturated compound. We are converting it to saturated. So all the arrows that are going out are indicating from the yellow highlighted compound are all saturated. So this is saturated alcohol. This is saturated. Compound Y will also be saturated. And compound X is also saturated. Because an unsaturated compound undergoes addition reaction so that, what do you call this? So that the double bond is broken down, which means you're not going to have multiple bonds anymore. So hence it becomes saturated compound. So there. So I know my compounds are all saturated outside of that alkene. I see Baba Long. So they are all saturated outside there. Then when we move into towards, I'm going to use green. This green represents the reverse of addition, which is elimination. So we are eliminating something. Whatever that we added, we must remove. You see that? So that is elimination. So what we added going out, we must eliminate going in. So what type of reaction is reaction E? What type of reaction is reaction E? Just focus on the green. Let me hear. What type of reaction is reaction E? Dehydration. Good. It is dehydration. Hi, Pasha, I think you did your homework this time because you were crying the other day. So yeah, I don't understand this. This is dehydration. It's dehydration indeed. So we are removing water then. Good. Now, what is what? No, not A. And let's look at reaction D. What is reaction D? What is reaction D? Let there be others who assist you, Pasha. Reaction D. What is reaction D? Think of what we added. Now we are removing it. Dehydrohalogenation. Good boy. Dehydrohalogenation. Thank you, Khotatso. Yes, Sekhametsi, it is dehydrohalogenation. And also reaction C. What is reaction C? Reaction C. Good. Can we all agree that reaction C is also a dehydrohalogenation? Can we agree that same? Yes, true. So this is also another dehydrohalogenation. So halogenation. Right. So I've dealt with them, and I want you to know that the dehydrohalogenation requires heat. That's the first. Dehydrohalogenation requires heat, and this one requires a strong sodium hydroxide for this to happen. That's when we can have those three compounds, Sekhamitsi. This it must be concentrated. Don't forget that. That's when we can have those three products from this. I hope that makes sense now, Sekhamitsi. And Dehydration. What do we need for dehydration? Forgot about that. The reaction condition for dehydration. Dehydration. Remove water. That's not a reaction condition. What do we need in order to remove water? Yes, we need heat. All elimination and substitution requires heat. And what else? We require heat. Remember, there is water involved. Once water is involved, what else do we need for that reaction to take place? We need alcohol. No, we are trying to actually change that alcohol to an alkene. So heat is needed. What other inorganic substance that is needed for this reaction to be possible? Another alcohol. Hypo. No, Pasha, no. So here we need H2SO4, and this is concentrated. So we need a concentrated sulfuric acid. Remember, when you add, you need to dilute sulfuric acid. As long as you're adding water, sulfuric acid must be there. Okay, so I spoke about that. Let me use color blue now to identify these other reactions that I've not spoken about. There's this one here. There's this one here. There's this one here. Just focus on blue. Just focus on blue. And if you look, blue moves from saturated to saturated. Saturated to saturated. Saturated to saturated. Thank you for bringing that. Yes, concentrated, it's elimination. Dilute is substitution. I think if I would remember, then I would just note it down here. Thank you, Hotatso. Okay. Substituted to saturated, saturated to saturated. So what type of reactions are these ones? When a compound is saturated and changes to a saturated compound, or produces a saturated compound, what type of reactions are these ones? All three are of the same type of reaction. They are substitution reaction. All of them, they are substitution reaction. This is also substitution. Now, siyabonga Baba Matiwan. Thank you for joining us. Abantu abadala ba. Yeah. And there's substitution reactions. Yes, there are substitution reactions. Sekhamitsi. Thank you, Mr. Matiwan, for coming through. Siyabonga. Cela ushare leyo link leyo nabafowethu lapho. And your learners too. Right. So they are substitution reactions. And also inform them that they will find this video in the morning. What do you call this? YouTube. So they are substitution reactions. Now, I want you to then tell me, I'm moving from, would you know that, right? Okay. We know, but we don't know, but we know. Compound X is a haloalkane. Compound X is a haloalkane because you said the reaction that it undergoes is hydrohalogenation. So we are forming a haloalkane. Now I'm moving from a haloalkane, compound X, to an alcohol. What type of substitution reaction is this one? What type of substitution reaction is this one? From compound X to an alcohol. It's a substitution reaction. So what type of substitution reaction is this one? All right, what is it? Yes, Pasha, it is hydrolysis. What do we need for this reaction to take place? For hydrolysis, what do we need? We need heat. Yes, we need heat. That's true, we need heat. Mild heat though, ne? And too much water. Too much water. You know the easy answer for learners, they'll just say, we need heat. Yeah, just know that for substitution and actually excess water, ne? Yeah. Oh no, just water, it's fine. For substitution reactions and what is the other one? Substitution reaction and elimination, they all need heat. Okay. Then this one, I'm moving from propane to a haloalkane. Remember compound Y, it's a haloalkane. It's a haloalkane. So now, from propane to haloalkane, what type of substitution is this one? What type of substitution is this one from an alkane to a haloalkane? I'm waiting on you. What kind of substitution is this one from an alkane to a haloalkane? All right. So we call this halogenation. Too late. But I already responded to it. But that's okay. Thank you. And what about from an alcohol to a haloalkane? Can we also confirm that or conclude that it is also a halogenation? Yes. So fine. I think I've done justice to the flow chart. Let us now look at the questions and how to go about responding to them. So, the first question, write down the type of reaction represented by A. Please go as simple as possible. Don't try to be fancy about it. Go as simple as possible. Look, triple S, Sue, USA. If you look at this, this is the C. This is the C. The C has a lot of reactions in it. There's a lot of reaction taking place in the C. This one we refer it as substitution. And this one we refer it as elimination. And the last one, there will be addition. Just go as simple as possible. As long they don't ask you the type, just give them the basic one. I know you want to show your muscles, but just go simple. Reaction A, according to Hotatsu, is saying that the answer here must be addition, in which I agree, because we are now taking in the information we have from our analysis there. What about reaction B? What is the reaction B? What is the reaction B? Answers are on the flow chart that is analyzed. It is substitution. Thank you. At least yeah. Substitution. Reaction E. Reaction E. What is the reaction E? Please do assist Sekhametsi in terms of gifting. Yeah, those flowers, they go a long way. They do go a long way. Thank you so much, Sekhametsi. So indicate what is reaction E? Reaction E. What is reaction E again? Okay. Reaction E, from the data, we said it is elimination. I'm not sure if you are unable to see this from the data I've analyzed for you, that you're not engaging with it. All right, 4.2 says you must then give an IUPAC name of compound X. So that one I didn't do, but let us look at compound, the unsaturated compound. We are referring to that propene there. So for us to have the IUPAC name, I can draw this structure for you. So this moves from so you have such, in which you're going to add HBr, and this will give us the following. So here I'm also showing you how to write a balance equation using structural formulas. So there you go. So this is what you're going to have. So the bromine, will go where there are fewer hydrogens. And the hydrogen itself will go where it's more recognized or familiar. So hydrogen will go where there is more hydrogen. Thank you so much to Pasha. Thank you for the right recognition. We thank you. So hydrogen will go where there are more hydrogen. That will be your Markovnikov. ZF or ZSF is for elimination, for you to find a major product. So they also mentioned major product. So yeah, so this is the balanced equation. But what we are looking for is this. So let's give it an IUPAC name. So it's going to be 2-bromo-propane. So it's 2-bromo-propane. So we come here and say, oh, the IUPAC name here is 2-bromo-propane. 2-bromo-propane. So then you get your 2 marks there. Okay. For reaction D, let's go and look at reaction D. Reaction D is the reverse of hydrohalogenation. So that is dehydrohalogenation. So the type of elimination. So we say, oh, okay, we have answers. Dehydrohalogenation. So see, then state 2 reaction conditions for this to happen. Someone please give us the reaction conditions that are needed for dehydrohalogenation. I can just show you here. Dehydrohalogenation. What do we need for this reaction to occur? What are the 2 reaction conditions that are needed for dehydrohalogenation? Talk to me there. Okay, it's fine. So the conditions there are the heat that we need, and we also need the dehydrohalogenation. We need concentrated, strong base. We want a concentrated strong base. So yes, so those are the reaction conditions for this particular problem. Right, now compound F. Write down the formula of the inorganic reactant needed for reaction F. So we want compound X to be converted to an alcohol. I'm not seeing any movement here. Yeah, so we want a compound X, which is a haloalkane, to be an alcohol. For us to have an alcohol from a haloalkane, we need water. If I don't need water, if I don't have water, I can use the strong base, sodium hydroxide. That's all that we need here. Okay. Sharp. So we need one of those. So balance equation. Write down the balanced equation using structural formulae for reaction G. Reaction G is an alcohol to a haloalkane, major product. So there we must have a chlorine. Remember, there's this chlorine that is going to form part of that. It's not the acid. It is the concentrated base, strong base, and what's that again? And heat. For heat, yes, you are correct. But thank you for that, for being there. I appreciate that, because your responses are also helping us to sort out some or iron up some of the things that one needs to know. Right. So for reaction G, an alcohol to a haloalkane. Remember, compound Y is a haloalkane. And thank you for that gifting. Thank you. So I'm going to erase this one. And my network on my side is kind of shaking, but it's fine. I'll proceed here. Like I said, some of things you'll find them on the YouTube channel. So compound G, we're starting with an alcohol. This alcohol comes from a major product, so it's also a major product. You remember we said this is 2-bromopropane, so the alcohol is going to be propane 2-ol to match up with the major product of compound X. So they said I must use structural formula. And I've realized that there's actually a question that wants you to write using condensed structural formula. So don't always expect what structural formula. You can be asked to write it in using condensed structural formula. And they will surprise you where you least expect it. So we need to move to a haloalkane. So we need HCl. Why I'm saying HCl, I'm guided by arrow that this addition reaction here, where we add HCl. So that means Cl must be part of compound Y. So therefore here I'll also need that. And also if I put Cl2, it wouldn't really make sense to have an OH that will bond with Cl. So with that, the product will therefore be, we are taking this one and replacing it with that one. So when we do that, we are going to have and plus water. There we have it. So this is your 2-chloropropane. 2-chloropropane. So I'm hoping this is making sense, right? Let me see with the hearts to show that whatever I've written here makes sense and you are happy about it. Yes, so you can see that, like I mentioned, I take long to answer the questions because my interest is on understanding what's happening in the flowchart. Once we can deal with the flowchart and understand it, applying all that we have learned, it can go a long way because most of the questions here, they're answered. Like 4.1 is answered, 4.3 is answered, 4.4 it is also answered, except for 4.2. But you can see that you have answered almost close to 80% of these questions that are asked here. So please engage with the thingy. What do you call this? The data provided to you, and add more through these flowcharts. Put more information there so that when you respond, you are just cutting and pasting from what you have actually analyzed. Can I get the thing, some inputs, suggestions? Can you please explain 4.4.2? 4.4.2. All right. Let's look at what is reaction G. Reaction G, we are moving from an alcohol. Then your question is, how did we get this alcohol? Do you remember they asked you to write an IUPAC name for compound X? And you said it's 2-bromopropane because you wanted a major product. So the bromine went to where there are least number of hydrogens, and the hydrogen went to where there are more. That's why we have the bromine in carbon number 2. So again, even our alcohol is a major product So that means the OH must replace the bromine in carbon number 2. That's why now we have propane 2-ol as our alcohol there. Now that we have this alcohol, and it must undergo substitution reaction to form a haloalkane here, because you can see the HCl shows that I'm adding it to form compound Y. That makes it a haloalkane. I hope you do understand that. So now, where is this haloalkane? The haloalkane is in carbon number 2. So we're going to use HCl. Then the Cl will replace the OH in carbon number 2. That's why we have 2-chloropropane and the water on the side. Aaron, does that answer you, mister? Internet. Does that answer your question? Oh, that's good. So if it does, I have managed to answer this question. I believe I did my best in that. And if you enjoyed this, please subscribe, follow, like, and share. And you'll find it on YouTube, of course. Thank you so much. Thank you.